Okay, so today we are really talking about series. And the difference between a series and a sequence is with a series you're going to add up all the terms. That's the difference. A sequence, you just list all the terms. Okay, I'm sorry. There you go. In a sequence, you just list all the terms. In a series, you add them all up, okay? So when it says find the sum of the first 5 terms, we get a little formula. And it's S, and the reason it's S is because we're going to be doing a sum. So there's 2 ways to do this. One is just to make all 5 terms, which will work, and then add them up. The other is to use a formula. Okay, I'm going to do both. So I need to make the first term A1. A1 is simply going to be 3 times 1 plus 5, which is 8. Right? I'm going to make the first term. A2 is 3 times 2 plus 5, which is 11, right? A3 is 3 times 3 plus 5, which is 9, plus 5 is 14. A4 is 3 times 4 plus 5. 12 plus 5 is 17, right? And then A5 is going to be a 3 times 5 plus 5, which is 20, okay? Now, I've made them all. I'm going to add them all up because that's what S means, the sum. So I'm just going to take my calculator and just go, okay, I can do this. Take my calculator and I am going to clear that. I'm going to go 8 plus 11 plus 14 plus 17 plus 20, and I get a grand answer about 70, okay? You can see that. So I can answer about 70, okay? Get that what I want. 70. There you go, 70. Okay, now, is there another way to do it? Yes. I notice that it's arithmetic. So if it's arithmetic, I go to my reading notes, and I could use this formula right here. It's arithmetic. So I could say, well, if I want to speed this up, I can go S of 5, thank you. S of 5 is equal to N, which is 5, times A1, which we know is 8, AN, which is 20, divided by 2. Okay? Now you can easily make the last term. So here's something to think about. You don't have to make all the terms. You just have to know and make the first term by plugging in 1. You can make the last term by plugging in 5, and you've got the first term, the last term. You know there's 5 terms total. So I'm using this formula right here, first term, last term, divided by 2 times 5, and I can just use my calculator and I'll get the exact same answer. Now, 5 terms, no big deal. I can just make all 5 and add them up, right? But if there's a lot of terms, having the formula is pretty handy. Yeah, Katie?
So wouldn't you still have to find A1 and A5?
Yes, yeah, you would. And some kids are going to say,
everything in between.
no, you wouldn't. And so then the moral of the story is this, Katie. If there's 100 terms, the formula is really worth it because you can make the first term easily and you can make the last term easily, right? If there's only 5 terms, you might say, I'll just make all 5 terms and add them up, right? So it's debatable. With a lot of terms, you're going to want a formula, right? Okay, number 2. Okay, this is a question. In fact, we're going to plug in 1, we're going to plug in 2, plug in 3, plug in 4, plug in 5. So if I find A1, it's going to be simply 2 times 1 minus 3, which gives me an answer of -1, right? If I want to find A2, I'm going to go 2 times 2 minus 3, which is +1. I want to find the third term. A3 is 2 times 3 minus 3, which gives me 6 minus 3 is 3. Seems arithmetic to me, doesn't it? If I want to find A4, I'm going to go 2 times 4 minus 3, which is 8 minus 3, which is 5. Yeah, it seems arithmetic to me as if I'm going up by 2's each time. A5 is 2 times 5 minus 3, which is 10 minus 3, which is 7. Add them all up, see what I get, right? Add them all up. Clear, I'm just going to go -1 plus 1 plus 3 plus 5 plus 7, and I get an answer of 15, okay? And again, would a formula work? Sure, we could have done this with the formula, and I'm going to show the formula as well so you can see how it works, okay? So if I use a formula, I know it's arithmetic, so I'm going to use, I know it's arithmetic because I'm adding 2 each time. I'm adding 2, so I'm going to use my arithmetic formula. Now, you don't have to use a formula. We already have the answer, but I want to use a formula so you can see how it works, okay? So I know that if I use this, S of n equals A1, oops, wrong formula, n, too many formulas, n times A1 plus AN divided by 2. Let's just use the formula instead. So I want S of 5 because I want the sum of the first 5 terms, right? 1 through 5. And n is 5. A1 is -1. AN is 7 divided by 2, okay? So I'm just going to use the formula. I'm going to plug in 5 for n, okay? Dave, you can turn around if you want to. You want to sit at my desk. Okay. And then if you use your calculator, sure enough, you get the exact same answer, 15, okay? Now, the formula is handy if there's a lot of terms, right? If you only have a few terms, you may as well just make every term and then add them up, okay? Capiche? Thumbs up? Seem pretty easy? Okay, number 3. Okay, number 3. So, it's the same thing, but this time we're going to make 6 terms. We're going to go A1 is equal to, let's see, 3 times A2 to the 1 minus 1 power. Okay. Anything to the 0, it's 0 power. Anything to 0 power is 1, so this just becomes 3. You can double check it on your calculator if you want to. You can say, okay, what is, clear, what is 3 times 2 to the 0 power, right, to the 0 power? And sure enough, you get 3, okay? A2 is going to be 3 times 2 to the 2 minus 1 power, which is 2 to the 1 power is 2 times 3 is 6, okay? A3, 3 times 2 to the 3 minus 1 power, because I'm plugging in 3. That makes 2 squared, which is 4 times 3 is 12. A4 is 3 times 2 to the 4 minus 1 power. 2 to the 3rd power is 8. 8 times 3 is 24. You start to see something. It might look like it's geometric, right? A5, what do you think A5 is? Without even doing any math, what do you think A5 is going to be? 48, right? And what do you think A6 is? 96, right? 96, okay? All right, so add them all up, right? Add them all up. Get my calculator out here. Add them all up, and I'm just going to go 3 plus 6 plus 12 plus 24 plus 48 plus 96. And I get an answer of 189. Okay? Now, could a formula work? Sure, absolutely, and I'm going to show you the formula. So is it arithmetic? Geometric? Which one is it? Geometric, right? And it took me a while, but I found it, right? So here's my geometric formula.
Well, you know it's going to be geometric, right? Because it's messing with exponents.
Yes, you're figuring that out, Claire. You're a day ahead of me. Okay, so I'm going to use this formula, which is my S of n equals A1 times 1 minus r to the n power all over 1 minus r. Okay? So I'm going to go S of 6 because I want to find the sum of the first 6 terms. S of 6 because I want the sum of the first 6 terms. A1 I know is 3. 1 minus the multiplier is 2 to the 6th power because n is 6 all over 1 minus 2. Okay, and if you use your calculator you get the exact same answer. Okay. Number 4. Number 4 is easy and not easy. There's no formula. There's no formula. But luckily, I only gave you 3, 4, 5, 6, 7. 5 terms, okay? All right, so let's make it. A1. Am I going too fast? Okay, A1 is simply, you got to plug in 3, right? 1/3. A1 is 1/3. A2 is 1/4. Because we start with 3, right? A2 is 1/5. A3, yes. Who said that? Thank you very much. A4 is 1/6. And A5 is 1/7. So there really are only 5 terms because you start at 3, right? You start at 3. So now if I have to add them all up, there is no formula. It's not arithmetic, it's not geometric, so no big deal. I can just use my calculator, right? I can go. You ready? I'm going to show you on my calculator. I'm just going to go and do this. I'm going to go and do a, let's see if we can see my calculator. Okay, scoot this forward, up. Mess with this. I hate it when those freshmen mess with my stuff. It drives me crazy. No, my freshmen. Today was a good day though. I already warned Mr. Hoya. I said I'm going to sacrifice some kids. First kid, boom, office. Anyway, let's go. 1 divided by 3 plus 1 divided by 4 plus 1 divided by 5 plus 1 divided by 6 plus 1 divided by 7. So just let my calculator do the work. There's 1/3 plus 1/4 plus 1/6. Enter, and I get a big old ugly decimal, 1.0 and a blah, 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 blah. Okay, if you want a fraction answer, you want to see some magic, some calculator magic, I go to math. It's on frac. It'll change it to a fraction for me too. Isn't that cool? Yeah, so I went to my math. So my answer is 153 over 140, or about approximately 1.09. How's that? Okay. Thumbs up so far? Okay, you ready to turn the page? All right, here we go. Now, here's the formulas that we were given the other day. Do you remember these formulas we were given these the other day? Okay, there's our formulas, our arithmetic formula and our geometric formula. So now what we want to do now is play Jeopardy. If I give you the series, can we put it in summation? So here's what I want to do. Summation form. Summation form. I need to put it in that form, okay? It's actually pretty easy. Honest. I Bill Davies say this is easy. Okay? So if we need a summation, just start there. Start with boom, boom, boom. Okay? Just start with that. And I don't make them very nice, but you know, probably some of you guys have better handwriting than me. Okay? Just start right there, okay? Let's start with n equals 1. So let's start with 1. So that's my first term, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to go all the way up to 11. Okay? Okay, one more time. Let's start with 1 because 5 is my first term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So to get 35, I will have to plug 11 into a formula, okay? Is this arithmetic or geometric? It's arithmetic, right? So let's put this formula down into here. Okay, so I'm going to write A1 plus n minus 1 times d, okay? If it's a formula, I need a variable, right? If it's a formula, I need a variable. So the variable I want to use is n, okay? So it's a formula, I need a variable. And I'm going to let my n be my variable, okay? So I'm going to go, okay, I can do this. I can do summation n equals 1 to 11 of 5 plus n minus 1 times 3. And that is the correct formula, except for I'm going to tidy it up. That's it. I'm going to tidy it up. That's it. If I were to plug in 1.
What does the D stand for?
The difference between each term. Good question. And so the difference between each term is 3, isn't it? D stands for the difference between each term. So D is 3, and A1 is 5, right? Okay, now, this is correct. If I were to plug in 1, 1 minus 1 is 0 times 3 is 0, gives me 5. But I can tidy this up, right? I can make that a 3n. So I can tidy it up, make it look more like this. N equals 1 to 11 of a 3n plus 2. Okay, will this work? We'll check it out. Let's see if this works. If I plug in 1, 3 times 1 is 3 plus 2 is 5. Boom. If I plug in 2, 3 times 2 is 6 plus 2 is boom. If I plug in 3, 3 times 3 is 9 plus 2 is boom. This formula works. And we're going to do it all the way until we plug in 11. If we plug in 11, boom, we'd have 35. Wouldn't we?
So every time you add, it's arithmetic and arithmetic.
Yes.
You multiply is
Geometric. Nicely said. Yes. Yes. And you know what, DeAndre? It'll take us a few days before that really sinks in, right? Okay. All right, now number 6. Arithmetic or geometric? Arithmetic or geometric? It is geometric. It is geometric. It is. And it is r equals a negative 2. That's why it goes positive, negative, positive, negative. I mean, you know, if you go, let me slide up. Check it out. If you go 3 times negative 2, you get negative 6. Times negative 2 gives you positive 12. Times negative 2 gives you negative 12. Times negative 2 gives you, see how it goes positive, negative by the negative? So r's got to be negative 2, okay? So sigma, start here. We need to start with sigma n equals 1. Let's see, there's, I don't know how many terms there are. Do you guys? There's a lot. Well, maybe not. Let's see how many terms there are. I know the next one's 96. Negative 96 times negative 2. Hold on. Negative 96 times negative 2. 192 times negative 2 is negative 384 times negative 2 gives me a 768 times another negative 2 gives me a negative 1,536 times another negative 2 gives me a 3,000. I'm almost there, believe it or not.
Wow.
Times another negative 2 gives me a negative 6, 1, 4, and then 4, 4, and then finally I get that one, okay? So how many terms are there? Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13 terms. Okay, you okay with that? There's 13 terms. Okay? And I can show you mathematically how to get that 13 without having to do all that. But I'll show that later, okay? You guys okay with 13 terms? I just made the whole thing, okay? Now, you said it's geometric, right? So if it's geometric, I'm going to use this formula, okay? So I'm going to use this formula. So I'm going to write in A1 r to the n minus 1 power, right? So I'm going to go ahead and rewrite it. Given the sum n equals 1 to 13 of 3 times negative 2 to the n minus 1 power. And that is my formula. Okay, that's my formula. And I think I want to talk about these tomorrow. Okay? So hang on to it, because these, you have had enough, all right? That's enough. Now let me give you a small assignment, but you need to do it, right? Right? So let me go find out what I want to give you for today. Chapter 11. We'll wait on these for tomorrow, okay?
Can we just do 5 problems like we did Friday?
Sure, if you guys do them, all right? We guys just got to do them. Right, Jacob? It's like, yes, Mr. Davies, I can do 5 problems, right?
I love playing.
Oh, it's not chapter 11. What chapter am I on?
No, we have to.
Oh, chapter 12. Okay, let's do... All right, let's do page 874. Let's do 6. And... oh boy, I gotta be really selective on these. No. Let's do, I should look through this. Let's do 17 and 18. We'll do 19. We'll do 25. And let's do 26. There you go. There you go. Page 874, and I'll stop recording and put this up on